I'm attending a hackathon in 3 hours, but unlike every normal hackathon where you make a program, at this one I'm going to be making a robot.
Welcome to Maker Hacks 2025.
Hey everyone, opening ceremony is starting now. Just before we start, I urge everyone who has their bags right in front of the meeting room to clear the walkway so it's not a tripping hazard or anything.
I would like to tell me a month ago to build a better tripod.
Like, what advice would you give, I guess, to someone who hasn't?
I'd say, start with a small idea and then grow that bigger. Don't start with something big and then be unable to finish it. Don't schedule your stuff to be done last minute because chances are a delay is going to happen and you're not going to finish.
With designing things, do you have any advice on like how like the design should be or be good, I guess?
If you need to 3D print something, like the strength changes based on the orientation. Like if you want it to be strong in one direction, make sure that one direction is like the layer adhesion between the parts. It's going to be not as good as the material strength itself. So it'll break easier along. So it'll break easier along the top to bottom axis.
Attention, please. First of all, thank you so much for making it up to San Francisco in the rain and the cold so early in the morning. It's great to see so many of you here. I am Rahul. I work at Century. I have nothing to do with the hackathon outside of these guys sent me an email and I responded. I had no idea what I got myself into, but this is really fun to see happen. I'm actually going to bring my girls here later tonight. They're 7 and 10, so hopefully they'll be inspired by all of your work. Clean up after yourself here. Help yourself to any drinks, snacks, candy, whatever the team's brought for you. And have a great time building whatever you're going to build today.
What's up? I'm MC and my name is Narain. So this is Maker Hacks 2025, which is the first hardware hackathon in the Bay Area, and it's based on robotics. Maker Hacks is a 30-hour hackathon where you'll build, test, prototype something that is amazing. The hackathon challenge are the 2 tracks you have already signed up for. The second track is a robotics challenge, an entire robotics season, which will consist of 30 hours of hacking, with revealed at the end of this opening ceremony. Teams will iterate and test designs throughout the hackathon, and at the end of the hackathon, we will host a robotics tournament to crown the winner of the robotics challenge. For the robotics challenge, think of it as a robotics season, but condensed into 30 hours. You will design a cat, build and test a fully functioning winning robot. Once completed, you will be able to compete in a field-based robotics competition using all provided hardware to your advantage, plus any CAD skills you might acquire. So let's move on to prizes. In both open prototype and robotics challenges, the third place team will receive a Hack Club swag and 1 hardware kit. For the robotics challenge, second place team will receive 1 3D printer and an Arduino kit, while the first place team will also receive 1 3D printer and admission to Blast AI's summer internship program along with scholarships.
Our agenda is as follows. At 9 a.m. the participants check in while the opening ceremony is happening now from 10:30 till 11 a.m. Followed by the start of our hacking period starting at 11 a.m. Dinner at 7, followed by a quiet evening until midnight snacks with a deadline for the open prototype and robotics challenge at 11 a.m. Closing ceremony will begin at 12:30, finishing by 1 p.m., the end of the hackathon. Per our event rule policies, no cheating, be fair, and integrity matters. Follow ethical guidelines, be kind and collaborative. All CAD files must be approved by an expert in the designated area before submission.
Yeah, hey guys, I'm really excited to do this. This is the first time it's ever been done in a hackathon. And it's going to be one-on-one. Teammates will start in opposite corners. The objective of the game is to score colored cubes. Yeah, how this will work is that you guys will be scoring colored cubes in these cake dot corners, colored corners in the sides of the field, and also these scoreboards in the top of the field. There are 3 colors of cubes. There are yellow, red, and blue cubes. So one-on-one being, one team will be red, one team will be blue, and the game will work with all of your cubes on the opponent side of the field. Your job is to retrieve your cubes and retrieve them back to your side of the field, thus scoring them. Alternatively, you can also score your cubes. You can come up the platform and score your cubes in the platforms. This will be worth more points. There's a full game manual that will be published on Discord shortly after the opening ceremony with all the point assignments and specific rules. Matches will be 2 minutes long. There will be a 20-second autonomous period during or at the beginning of the match. There are these green lines at the bottom of the field. By crossing the green lines, 1 point is retracted from your score. So yeah, you basically need to retrieve your cubes to your side of the field. You may have to descore opponent's cubes, and there will be 10 yellow cubes in the beginning, at the bottom of every match. These yellow cubes will be worth more, and they also cannot be descored, but they will also be able to be taken by your opponents. We're currently counting for 16 teams. If that goes up or down, we'll adjust that in the bracket. We're going to create the bracket shortly after Team Mixer when we finalize the teams. But it'll be a double elimination bracket, so for a few of you guys in robotics, you may have had experience with bracket style, but basically what it means is that you have the opportunity to win even if you lost 1 match. Once you lost 2 matches, you're out. Alright, I think that's it from us. We're a little bit over schedule, but yeah, this is the beginning of hacking. You guys are free to finish. Lunch will be served at 1 p.m. We'll have a pad workshop happening very soon. More hints about that.
Alright, we got this. Our setup is right here. Set up like a little area right here where we can do stuff. So what's your name? Alex. Alright, yeah, and what do you do?
I know mostly programming stuff. I do robotics at my school, but I also know basics of electronics.
I mainly do CAD, yeah.
Fantastic. CAD's what I'm worst at.
Okay, so usually when I attend a hackathon, I do it with one of my friends or by myself and then spend 5 minutes brainstorming and build a horrible project. This time, however, we spent quite a while brainstorming, which was probably a good thing. Alright, okay, plus 5 for crossing. Wait, what?
120 seconds. First 20 seconds is awesome.
Wait, what is this? They said we get points for crossing the green line?
On your side?
No, it says plus 5 and plus 7.
Oh, that's autonomous.
Oh.
Get
What if we
12 points
run
and then
across
just
one
cross
line
the
and
side,
then
you never have to cross the line
What
again.
if we run across one line and then just repeatedly move across that line? Would that count? Oh, there's a limit of 3 cubes being carried out once.
Okay, 3 cubes at once.
You may not intentionally break stuff, you may not descore your opponents. There are no restrictions on how many cubes. But it never says we can't just go to one line and then ping pong between it.
I don't think if it's dropped from the top, it has to be touching the back. It says 5 points from scoring from the bottom. This defines when the cube is touching the back of the scoreboard and pushed in. If the cube falls out, we just grab it and score it again. Like, it's not technically in the thing. So I'm assuming they have a rule against grabbing the thing out of the slot. However, if it's fallen out, we've gotten 7 points for dropping it in technically. Could we get another 7 points? So, okay, a yellow cube in your zone is the same amount of points as the minimum points for getting one on the scoreboard.
Yeah, so let's focus on scoreboard then.
Yeah. Team name.
It doesn't have to be C.
Can it be please suggest a name? That part's definitely going into the vlog.
Anchor here, you swing this arm up and down, and then you have something on the end holding.
I'm not sure how to CAD that though. I'm not completely
I
sure
think
what.
if you can, in theory, if
I can
you rig
steal
up
models
some
from
sort of-
Thingiverse. How is the CAD workshop?
Haven't started yet.
Wow.
Technical difficulty. How are you guys doing?
We're slowly figuring out the design. It's going okay. I'd like to get a first prototype finished before midnight so we can spend a lot of time in I'm not sure how simple that is. I've never done robotics before. I just want to finish a prototype earlier.
Okay, rules clarification. The points for crossing a line in Auton are a one-time thing. You cannot ping-pong back and forth across the lines. However, you can score cubes in Auton. It's the same amount of points as during the teleoperated phase.
Okay.
You only get one scoreboard if the side opposite where you're standing, so you can still see it when you're driving. If a cube fell out after dropping it in from the top, you would still get points for it because it's counted when you drop it. However, you can't score it again, I don't think. You can carry 3 cubes, but it doesn't matter how you carry them. And then the yellow cubes only score points on the ground. Putting them in your scoreboard would do nothing. However, they also start in a line of 5 across the middle, so you can't just drive straight through an Auton.
Okay.
You have to path around them.
Yeah. Yeah, I use Onshape for complex stuff now.
In theory, I was taught how to use Onshape and then I forgot it all, and my school uses Fusion for everything.
Oh. I don't like Fusion. I like Onshape. Originally, I planned to make 2 motion systems, one with a gearbox and the other with 4 motors. However, I gave up. Yeah, I'll just use Tinkercad to get a rough design done. You only use Onshape if it gets too complicated. The mechanism we ended up using to pick up the cubes was a robot arm made of 2 servos and a spatula at the bottom that would scoop up the cubes. That gives me a millimeter of margin on each side because I do not trust those 3D printers. I do not trust myself either, but I trust the 3D printers less. This is the regular frame design I have. It's made of this center part and these 2 parts.
Okay.
So, hopefully that'll be stable enough.
Okay, so are the side parts just like screwed in?
These ones are screwed in. This is just a bracket to align everything.
Okay, how are we gonna screw it in?
There's holes here, and then there's a hole inside this part.
Okay, great.
Alright? Extension.
Okay, how are you guys doing?
I'm working on CAD. I'm starting to figure out some of the Arduino stuff.
Yeah.
I do need to figure out how we're gonna have the computer connecting to the Arduinos, so we can actually write commands off it while we're doing it. They were saying use the Wi-Fi
I
interface.
thought we were talking about using micro-Python.
Yeah. But even with the MicroPython, we need some way to control the actual control from here so we can run different commands and actually operate the robot during the time.
Yeah.
Which I think we need to bring it to the Wi-Fi.
Design version 1 is complete. I'll work on version
I think
2.
there might be an API.
There is somewhere Wi-Fi still.
Let me take a look at their.
I think it's just using that to connect.
So for print jobs,
Is this for ESP32?
Yes, this should all work with ESP.
Because it's just a general microcontroller.
Yeah, and a lot of these examples are running on the ESP.
alright.
That seems surprising since it's Arduino. It's basically everyone uses
Okay, I'll try the gearbox now.
It's an Arduino
framework, right?
Let me get this print approved first, so we can test the 4 motor design before I
Pretty true. Alright, so the funny thing about this is going to be, in order to connect to the Wi-Fi here, it has to pull up the captive combo. However, I don't know if that will work with this, so we're just gonna try it and try it.
Yo,
Pray to the machine god, pray to your widow spirits.
I'll just type in your This is the awkward time during the hackathon where I finished most of the CAD and I'm waiting on the prints. But no one else has finished them, so they didn't decide to send any of the prints over until there were a bunch of them done. I'm gonna assume that we can steal models from Thingiverse.
These wheels don't feel very good.
They're better than PLA.
They're squishy.
They're squishy. They are squishy. Alright, I'm taking my phone around the hackathon. There's this whole table right here that's just all parts. And then I need to get a print approved. There's another rack thing back here. Bunch of random games. All of these tables, I'm working at one of them. More tables. And more tables. I'm gonna need a lot more of
Where
these.
did you get that?
You can ask them.
You're your third can of Pepsi?
Yes.
Oh my god.
I need the caffeine.
What's your team? Like, you know, micro SD card.
Please suggest a
We
name.
really appreciate that. You're trying to with us.
Do you have a team name?
That's our team name.
It's not a team name without your team name.
Our team name is Please Suggest a Name.
Yeah.
So I have... Printing stops at 10. I gotta hurry up and get the CAD done. How obvious is it that I have no idea what I'm doing? Hold on, I'm gonna go measure something. Shoot, no, I don't have a ruler. Wait. This is, wait. I can use these as a ruler. This is 51 millimeters. This is 60 millimeters. This is 56 millimeters. I know the exact measurements. Wait, actually, let me make sure that. I'm not sure what that is. Let me check this one, actually. This is the Ausu WRM. Should say here. Oh wait, no. This is 51. This is 56. Oh my god. This is 59. So if I have dimensions for all of these, I could go measure something with these cubes. I found an alternative for a ruler. Okay, they said ETA 2:30. It's 2:53 and I don't have anything. They said, I just asked them, they said 30 more minutes. Got some parts back. Let me get a date. But these supports aren't. I could have sworn I told them to print 2 of these. print.
I prayed to the machine god and the machine spirits, which apparently half worked. I connected to something, and it's printing something. However, that something is uncharacterized gibberish, and this is so nicely, and then over here I'm trying to put the wires together with duct tape. Oh my god!
They should just.
Why couldn't it all just be pinned like the breadboard and noodles, or like this? Like, this is so much nicer than whatever nightmare this is.
They
Like,
could just have these blue things.
Ideally, we could fix that now.
oh, okay, everything's wired. I think.
So we have.
think everything's wired.
I think, yeah, all the mechanical stuff is coming together. Ideally, I would be able to turn this around. That would move the wires from here. That would cause some other issues.
What are you doing?
Testing if Gorilla gluing together pieces of metal will make them not conductive. Science.
Let me see if I can do some math. I qualified for Amy 2 times. I might be able to do some math. 30 millimeters is the radius of the wheel. Distance from this thing to that thing, 13 millimeters. And then the distance between the wheels, let's call it 80 millimeters. We get a diagram over here. So we have 30, and then so we have that attached, and then there's 13 millimeters of space there. So 13 there. So then the remaining clearance down here would be 17. We want this angle right here, given that this is 80, yeah, this is 40, and then this is 17. So I need to find that angle right here. So this, with this angle with respect to this, with the tangent is opposite over adjacent, so 17 over 40. So I'm going to do arctan 17 over 40. Okay, that's in radians, I believe. And 23-degree angle should be about the most we can do. And then I'll go measure that thing and calculate the angle there. That thing has 70 millimeters for one of these high. One of these high is 37.5 millimeters. Arctan 37.5 over 70 over pi gives us a 28-degree angle, so we cannot clear it. So we have approximately a 28-degree angle here.
No, that's too hard, bro.
Yeah,
On the ramp or on this?
on the ramp. We can clear at most a 23-degree angle. So that's a problem. Shortening the distance would be the best solution. Yeah, but 10 on each side. So it would be turning that 40 into a 30 here, and this one's still 17. So now I do arctan 17 over 30, and then convert to degrees. That lets us clear a 29-degree angle. We're barely there. If it works, yeah, we can clear that gap by 1.5 degrees.
But that's all we need.
Yeah, that's all we need. Yeah, so if we can
Worst
get that
comes to
done,
worst, we start taking duct tape and wrapping it around the wheels.
yeah.
I remember on our
yeah.
robotics team 2 years ago, the way that our robot works is you have West Coast drive just like this, you get 3 wheels on each side, and then you make center drop, which is you put the middle wheel slightly lower so that you can turn more easily. But we didn't put center drop on it because there was like a big platform mechanism. We were like, okay, we don't want to slip around too much on it. So we didn't put center drop. Then we could turn. We were like, well shit, now we need center drop. And so the solution was to take like line belts and just wrap it around the middle wheels and screw it into place with wood screws.
That sounds
It was awful, but it worked. And we kept shredding carpets because we had wood screws sticking out of our wheels.
Okay. So many amazing things happened during this hackathon, so many that I couldn't include it all in one video or it'd be an hour long. So thanks for watching part 1 of Maker Hacks, and stay tuned for part 2.